All right, this is section A, sets and the real number line. So today we're going to talk about how to use interval and set builder notation to describe the union and intersection of sets. So first off, what is a set? A set is a collection of items that are called elements. A set that contains no elements is called the empty set or the null set. We're also going to use something called set builder notation. It uses braces, which are those curly little bracket things, and those are used to enclose the elements of a set. So we start with the braces, that's the set of. Then we say which variable, all x. Then we use a line for such that, and then we give an inequality, so x is less than or equal to 2, and then we close with our end squiggle. Interval notation is the one we'll actually use more commonly. Inequalities actually define intervals on the real number line. So if I tell you that x is strictly greater than 2, we could write x is greater than 2. Or on the number line, we would have an open circle on 2, arrow going to the right. The interval notation for that is parentheses, 2 comma infinity, parentheses. Because we start at 2, we go on to infinity, and we don't actually include either of those. So the way interval notation works is that we have a start number, an end number, and a symbol on each end. It'll either be a parenthesis or a bracket. Parentheses mean that the value is not included, but very, very, very close to it is. So if I had a 2 with a parenthesis, it means 2.00001, but not quite 2 itself. The brackets mean that the value is included. So if I have a 2 with a bracket, it means I can get I can hit very, very close to 2, but I can also get to 2 itself. And positive and negative infinity are never included. They always, always, always have parentheses. Little bit of vocabulary before we start. A bounded interval has numbers at both endpoints, so it doesn't use an infinity at all. An unbounded interval has an infinity at one or both endpoints, so negative infinity on the left or positive infinity on the right. A closed interval contains both endpoints, so it has brackets on both ends, and an open interval doesn't contain at least one of those endpoints. So we're going to interpret what each interval means. The first one is bracket 5, comma 10, parentheses. This means all numbers starting with 5 up to, but not including, I'm going to shorten including, 10. So all the numbers from 5 to 10, but not quite 10, but we do count 5. For the second one, parentheses 7, comma infinity, parentheses. This means all numbers 7 above 7. So 7.000001 is counted, but 7 itself is not. Parentheses 9, comma 100 bracket. So we start at 9, we end at 100. We don't include 9, but we do include 100. So this is all the numbers above 9 and less than or exactly equal to 100. 9 to 100, counting 100, not counting 9. The fourth one, negative infinity, comma, negative 5, with a parenthesis in the front and a bracket on the negative 5, means everything that's less than negative 5, and it includes negative 5, all numbers negative 5 or less. Number 5, parentheses 3, comma, negative infinity, parentheses. Well, 3 being in the front means it should be everything bigger than 3, but negative infinity is not bigger than 3. This interval means nothing. That is impossible. The sixth one, we have bracket negative 10, comma, infinity bracket. Well, this also means nothing because an infinity can never have a bracket. It should always be a parenthesis. So now we're going to take those same interval notations and we're going to rewrite them as an inequality. So bracket 5, comma 10, parentheses. Well, the smallest we can get is 5. The biggest we can get is 10. We put our x in the middle. And anytime the x is in the middle, our signs should both be less thans. It does include 5 though, so we need an or equal to on the 5. It doesn't include 10, so it's just a less than. When we have 7 comma infinity, everything greater than 7, well then x is greater than 7. Don't worry about an infinity sign in our inequalities. Parentheses 9 comma 100 bracket, well we take this number, put our x in the middle, our 100 last. We don't include the 9, so it's just a less than. We do include the 100, so it's a less than or equal to. Number 4, negative infinity to negative 5. Well, that means that x must be less than negative 5. The negative 5 has a bracket though, so we put our inequality there, or we're equal to. 3 times negative infinity, that's impossible. That doesn't exist. And negative 10 to infinity with a bracket, also impossible. If the interval means nothing, then I can't write it as an inequality. And now we're also going to talk about how these translate into a number line. So I'm going to draw myself some quick number lines here. All right, first one, my important numbers are 5 and 10. So I need 5, 6, 7, 8, 9, 10. Second one, my important number is 7, 10, I got 4. Here I have 9 to 100. Let's say that's about 50. Sure. I got negative 5 here. Negative 8. I have 3 as my important number, so just add numbers on each side, make sure everything I need is there. Negative 10, 7, 15. There we go. All right, for the first one, 5 to 10. Well, that means I'm going to have an endpoint at 5 and an endpoint at 10, and my graph is going to go between those two. Now, open or closed is based on whether the endpoints are included or not. The 5 is included, so I fill in that endpoint. The 10 is not included, so that is open. For 7 to infinity, I put my circle on the 7. To infinity, infinity is all the way to the right, so I put an arrow because it goes on forever. I do not fill in that circle because the 7 is not included. For 9 to 100, I'm going in between those two, so I'm going to connect them, pretend that was straight. And the 100 is included, but not the 9, so I'm going to fill it 100. For negative infinity to negative 5, I need my circle on negative 5. This time, negative infinity is to the left, so my arrow's going to the left, and my circle is filled in because that negative 5 is included. Number 5 and 6 actually don't mean anything, so I didn't even need to draw these number lines because it's impossible to graph them. All right, let's write these inequalities as an interval. For our first one, 5 is less than x is less than or equal to 50. Well, if I have 2 endpoints, those are the 2 numbers that I separate with a comma in my interval notation. The 5 does not have an or equal to symbol, so it's got a parenthesis. The 50 does have an or equal to, so it gets a bracket. Negative 2 is less than or equal to x is less than or equal to 7, so I put my 2 end numbers, negative 2 comma 7. Both of those end numbers are included, so I put brackets on both ends. X is greater than 2, so that means 2 and up. So 2 comma, well the biggest possible number out there is infinity. Infinity always gets a parenthesis, always, always, always. And since the 2 is not included, it also gets a parenthesis. X is less than or equal to 100. Well, that means smaller than x. So the smallest possible number is negative infinity. The biggest it can be is 100. Negative infinity always gets a parenthesis. 100 is included, so it gets a bracket. Our possible grades as a percent. Well, the lowest possible grade you can get is 0, and you can actually get a 0. It's just very difficult. And the highest possible grade you can get, it actually maxes out at 100. Is it possible to actually get 100? It sure is. And then all possible real numbers. Well, the smallest real number is negative infinity, and the biggest real number is positive infinity. Those are never included, so we use 2 parentheses. All right, we're going to fill in this quick table. I have a graph. Now this one's graph is set up a little differently. It used a bracket instead of the filled in dots. So I just changed that real quick. So I have a closed dot on 2, and my arrow goes to the left forever. So my interval is negative infinity, as far left as I can go, comma, as far right as I can go. Negative infinity always gets a parenthesis. The 2 is filled in, so it gets a bracket. My inequality, well, that means everything that's less than or equal to 2. So x is less than or equal to 2. For my second one, I have the interval notation, 7/2, comma, infinity. So I need to mark it 7/2. 7/2 is 3.5, so we'll go, that's 3, 4, 5, 2. All right, it's not included, so I have an open circle at 7/2. It goes to infinity, that means to the right forever. There's my graph. My inequality is that this means everything greater than 7/2, so x is greater than 7/2. My last one gives me the inequality. -4 is less than or equal to y is less than 2.3. The interval notation is easy here. I take my left endpoint and my right endpoint, separate it with a comma. The 4 is included because it says or equal to, so I put a bracket. The 2.3 is not included because it's just a less than, so I use a parenthesis. On my number line, I need -4, 0, 1, 2. Okay, so at -4, I'll have an open circle. At about 2.3, I'll have a filled in. Oops, I did that backwards. I'll have a filled in circle at -4 and an open circle at 2.3. And then I connect between the two of them. Pretend I had that right the first time. We also need to talk about unions of sets. The union of sets A and B, denoted A with a little u, B, is the set of elements that belong to A or to set B or to both. So if you think about this as a Venn diagram, it's anything that's just in A. It's also anything that's just in B. It's also anything that is in both. That is your or, the little U symbol, your union. An intersection, on the other hand, is denoted with the upside down U that kind of looks like an N. This is the set of elements that are common to A and B. So this is just what they have in common. All right, just where they overlap. Little meme of the rock to help you picture that. All right, we're going to find unions and intersections as indicated. The first one, A, and then that symbol B, that means and. I'm looking for what they have in common. So what do sets A and B have in common? Well, they both have a -5. And that's the only thing they have in common. So the only thing in common between sets A and B is -5. The second one, this is an or. Anything that's in A, or it's in B, or it's in both. If it's in both, we only write it one time. So first thing, -5 is in both of them. So that'll be our first element of our answer. I've got a -3 in at least one of them. I've got a -1. I've got a 0. I've got a +1. I've got a 5. Generally, we try to go in order smallest to biggest and then put it in some braces. Second one, A and C, that upside down N, that's an and. What do they have in common? Well, if I compare my numbers, they don't have anything in common. So I can actually use this symbol. That means the empty set, there is nothing actually in common. Notice it's a 0 with a line through it. Please be careful not to make your zeros as zeros with lines through them. Now we're going to do this, but in set builder notation. In set builder notation, I find it easier to draw myself a little bit of a number line. Okay, my important numbers would be 4, -2, and -3. All right. -3, -2, -1, 0, 1, 2, 3, 4, 5. All right, my first set is going to be D, that is x is less than 4. That's an open circle on 4, arrow to the left. That's D. My second set will be E, x is greater than or equal to -2. That's a filled in circle at -2, arrow to the right. That is E. And my third one, x is less than or equal to -3. That's a filled in circle at -3, arrow to the right. That is f. All right, so my first problem is asking for D and E. It's an and, remember? So what do D and E have in common? Well, that's everywhere they overlap. They overlap starting at -2, and then they stop overlapping at 4. Now, -2 they both have, so I use a bracket because it's included. +4, only one of them has, so it's not included in the parentheses. Now, if I want to write it in equality also, I put -2 is less than or equal to x is less than 4. Second one is D or E. So anything that's in D or it's in E or it's in both. Well, the smallest D goes is -infinity. And the biggest E goes is +infinity. Those always get parentheses. That's everything included. I actually can't write that as an inequality because it's all real numbers. All right, D or F, remember upside down U, or the regular U is or. It's in D or it's in F or it's in both. Well, all of F is covered by D, so we just need to go with what D's interval is. The smallest D goes is -infinity, always with parentheses. The biggest D goes is 4, with a parenthesis since it's not included. As an inequality, this is that x is less than 4. Finally, we have E and F. The upside down U is an and. What do E and F have in common? Nothing. You'd say no solution. They don't have anything in common. We can't have D and or E and F. Now we're going to do the same thing, but I have 3 intervals, and I'm going to write it as a single interval. I again think that a number line might be helpful. I need my number line to go from -3 to +4. All right. My first interval is -2 or -infinity, comma 2 with a parenthesis, so it's an open circle. My second is -3, so an open circle, to 4 with a bracket, so a filled in circle. And my third one is 1 with a bracket, so filled in circle, to 3 with a bracket, so filled in circle. Now, all 3 of these are asking for and. It's the first one and the second one and the third one. So really, we're looking on our graph at where they overlap. Well, they start all overlapping at 1. And all 3 of them contain 1, so that's going to be a bracket. They stop overlapping here at 2, where one of them ends. And that one's not included in this first set, so I use a parenthesis. My only overlap of all 3 of those is 1 to 2, including 1, not including 2. A couple other important definitions. A term. Each term is a part of an expression or equation separated by addition or subtraction. An expression is a mathematical phrase with numbers, variables, and operations. A constant term is a term with no variable. A coefficient is the number multiplied with a variable. And just a real quick reminder, make sure you remember the order of operations: PEMDAS, parentheses, exponents, multiply, divide, add, subtract.